Welcome to our very last lecture of Unit 3, Composition of the Earth. Let's get started. So the rock cycle is a series of changes and processes that cause rocks to break down and form new rocks. Basically, all rocks are constantly being broken down and turned into other forms of rock, and we're constantly making new rock. Remember when we talked about how magma can rise to the surface and cool, or how it can actually break through the crust and come onto the ground, and we can see it in the form of lava and it cools that way, and we form igneous rocks. Well, we're constantly forming new rock that way, and then the rocks that we do have are constantly changing forms between igneous, sedimentary, and metamorphic rock. And the rock cycle is the description of how that happens. So we're going to talk about the four main processes that lead to this whole rock cycle. The first one is melting and solidification. So it's the melting and cooling that I just talked about with those igneous rocks. So basically, all types of rocks can end up being buried over time. And when they're buried, what will happen is that they will be exposed to high heat, and sometimes they'll melt. And then after they melt, they can cool through the processes that we talked about, and they can solidify to form new rock. When this happens, they'll form new igneous rocks. The second process of this rock cycle is weathering and erosion. So the rocks that we already have on the surface of the Earth can be in the form of igneous, sedimentary, or metamorphic. And all three of these rocks are constantly exposed to natural pressures, things like wind and weather and water and rain. So all of those natural phenomenon are constantly going to be breaking down and kind of attacking the rock, you can think of it. So this will break the rock down into tiny sediments, little particles of rock. And all of these different types of rocks in their particle form can then be easily carried away by the wind or water. Then what happens to these particles is they go through deposition and compaction. We talked about this when we discussed the formation of sedimentary rocks. So these sediments will travel and they are eventually deposited. Remember, deposition, where they're placed into a different location than where they came from. Over time, all of these deposited sediments will be pressed down by the weight of all the sediments on top of them, or the weight of the water on top of them, or even the air, and this will compact them, and eventually they'll go through cementation and become sedimentary rocks. So that's how any type of rock, whether it be igneous, sedimentary, or metamorphic, it can be weathered and eroded, and the particles from it can then be turned into sedimentary rock. The last one, any rock, like we said at the beginning, can be buried. Well, sometimes they don't just experience high temperatures and melt. Sometimes what will happen is they will be exposed to high temperatures and high pressure at the same time. So all this pressure and all this heat, remember, it turns the rock into metamorphic rock. So no matter what type of rock it was before, under these conditions, we are going to form metamorphic rock. So the four processes of this rock cycle, you've got that melting and cooling, where we will form our igneous rocks. So we're constantly going back and forth between melting and cooling from magma. Metamorphic rocks can melt, sedimentary rocks can melt, they all can melt and then reform as they cool into igneous rocks. Then any of these three types of rocks can be weathered and eroded, and we're going to talk about those processes more in the next unit. But right now, just know they're natural processes of breaking down the rock. Remember, they can all be eroded and turn into sediments. And these sediments will be compacted, deposited, cemented to form our sedimentary rock. And that sedimentary rock or igneous rock can be placed under high heat or pressure. Even metamorphic rock can be buried and placed under high heat and pressure and then turned into metamorphic rock again. So this is just the way that all types of rocks cycle between each other. So I showed this video in class the other day, but a lot of us were absent, and I think it really sums up all of this pretty well. So we're going to watch it one more time right here, all right?
We're talking about rocks on this episode. Geology. In fact, rock types.
Rock types.
Probably sitting there now thinking, why do I need to learn about rock types? Why did I click this video? Well, I'll tell you, rocks are cool. Even if you're not going to be a geologist, it's really important to know what you're looking at. For instance, we do a lot of rock climbing, we do a lot of adventuring. We went last week to Red River Gorge in Kentucky, world famous for its rock climbing. And you talk to any rock climber there, they're going to know what rocks they're looking at.
It's composed of Corbin sandstone, which is a sedimentary rock.
Now besides that, it makes you sound smart in general because you look at a rock face, especially beautiful arches or deep canyons, and people, very commonly ask, how did this form? Where were these rocks before, right? And so if you know a little bit about rocks, you can take a stab at that answer, and even if you're not right, you sound pretty smart doing it. But first, you gotta know rock types.
The igneous.
Now start with the igneous because it's the natural place to start. It's where new rock is formed from molten magma. You see, a couple years ago, Haley and I went to Hawaii. We marched out along the coast of the big island of Hawaii, and we were able to see new rock forming when none existed before.
Glowing behind us, new earth being made.
It's lava forming igneous rock.
When that lava, or magma in some cases, cools, it becomes an igneous rock.
Right there. If you were wondering how rocks were formed, there you go.
Now, when magma cools slowly, it forms really beautiful crystals. The slower it forms, the bigger the crystals, right? So if you were, say, climb the Grand Tetons, which we did last month, you're able to see these giant crystals on the surface of the rock, and it's just awesome. Moving on, sedimentary rock.
Sedimentary rock.
Sedimentary rock is really cool because every sedimentary rock came very clearly from other rock, and you can almost look at the grains and see it because that rock basically got cemented together from the parts of other rocks. Got cemented together. How cool is that? And maybe the coolest manifestation we've seen is when we went through the Grand Canyon. And not only are you seeing these giant cliffs of exposed sedimentary rock that, are going back millions and millions of years, but you're actually on a river that is actively moving sediment away and depositing it somewhere else.
Metamorphic rock.
The metamorphic rock is just when you take any of the other rocks and you put them under heat and pressure and you twist them and meld them up. Now here's a rock climbing place in Golden, Colorado that we like to climb. That's metamorphic rock. One of the coolest places. First, to get to it, you gotta climb up a tree and zip over on this cable, and then you're climbing up the wall. And one of the things you'll notice is that when you're climbing the wall, the whole wall is like twisted and melded up. And that is metamorphic rock because it used to be granite. The reason for me wanting to tell you about rock types is just to get across the point that rocks change. You see, if you were to look at a rock cycle, you would see that any of the rocks, if they get broken down into little pieces, they can reform into sedimentary rock. If you take any of the rock types and you heat them up until they become molten magma, when they cool, they'll become igneous rock. And then likewise, if you were to take any of those forms and put a lot of heat and pressure on them, they will become metamorphic rock. So almost every rock can become another rock in this giant, cool rock cycle. So there you have it. Rocks are pretty cool, especially the more you know about them. If you clicked